Ada Yonath was born in Jerusalem in 1939. Her father was a rabbi who ran a small grocery store and struggled to support the family. Ada lived in a crowded apartment that her family shared with another 2 families. These meager beginnings did not suggest an illustrious career in science, but Ada's natural curiosity would pave the way for a bright future. As a child, Ada often conducted experiments around the house. Her indomitable spirit was evident from an early age. When she wanted to measure the height of the apartment's tiny balcony, Ada built a tower of tables and chairs. This undertaking ended with a broken arm. A second experiment to determine whether water moved faster than kerosene accidentally started a fire. Never discouraged, Ada continued to ask questions and seek answers. When she was 11, her father died, and her mother was unable to continue running the store. The family moved to Tel Aviv in search of greater opportunities. Ada's exceptional intelligence caught the eye of her school principal, who offered her free tuition in exchange for tutoring other students. In this way, she was able to receive an excellent education, while also working in restaurants and factories to help support her family. She spent her little free time reading whatever she could find. After serving in the Army, Ada went on to receive a Bachelor of Science in Chemistry and a Master's degree in Biophysics at the Hebrew University. In 1969, she completed her PhD in X-ray crystallography at the Weizmann Institute of Science, the institution that would serve as home for her next 4 decades of groundbreaking research. During a short postdoctoral period at MIT, she mastered the method for determining structures of biological compounds, returning at the end of 1970 to establish the first laboratory of this kind in Israel. By 1979, Ada had chosen the ribosome as the focus of her work. These tiny structures are found inside every living cell. Like little machines, they build all the proteins that cells need for life, everything from hemoglobin to insulin. When Ada started her research, world-renowned scientists had already been trying and failing to decipher the structure of the ribosome. To achieve this goal, namely see the ribosome's insides, crystals of ribosomes must first be prepared and then irradiated by X-rays. However, because ribosomes are made of many components and therefore tend to disintegrate, other researchers who had tried had come to believe crystallization was impossible. By 1980, Ada and her team successfully created the first ribosome crystals in history. Proving it was possible, the technique was rapidly adopted by labs around the world. This pioneering discovery continues to provide vital insight into one of the most pressing medical challenges of the 21st century, antibiotic-resistant bacteria. Now, scientists around the globe are able to use Ada's research to create more effective antibiotics. Throughout her career, Ada placed great importance on the value of partnership. In 1988, her work gained the attention of philanthropist Helen Kimmel.
It's been a wonderful relationship.
And a new type of partnership was formed. Inspired by Ada's life story and the innovative nature of her work, Helen began to fund her research. This melding of science and philanthropy created a lasting friendship. To this day, Ada holds the Martin S. and Helen Kimmel Professorial Chair of Structural Biology at Weizmann. Recognition of Ada's major contribution to scientific progress culminated in 2009 when she was awarded the Nobel Prize in Chemistry, along with 2 other scientists who contributed to our understanding of the ribosome. Ada is passionate about fostering scientific collaboration between Israel and its neighbors, and about encouraging the next generation to pursue careers in science. Ada Yonath's creativity, tenacity, and spirit of innovation continue to fuel her mission to understand the most basic building blocks essential for life.